don't want to do Fortnite. He's probably actually playing it right now.
Who, Connor?
Yeah. What was that term from the Haney test?
Soapbox.
Saltbox.
Nah, dude, Gable.
All right.
Gable.
All right. The phrase is saltbox. If you send me a message with saltbox to my email or tell it to me in person, I will give you a little W stamp. Gotta be the first one though. So see if you actually watch this, Connor. All right. Here we go. All right. So we want to be able to look at exponential functions right now. And an exponential function looks like this. It starts out really small and then it gets significantly larger. Okay. And there's a few things I want to talk to you about it, okay? It passes through the coordinate 0, 1, and here's y. Suppose I have y is equal to 10 to the x power, okay? There's a couple computations I want you to do. What is 10 to the 0 power? 1. So that's why it goes through the coordinate 0, 1, because if you plug in 0, you get 1. What is 10 to the 3rd power? 1,000. So do you see that as you move to the right, it gets large very quickly?
Uh-huh.
And then what if I have 10 to the negative 3 power? That's not 1,000, but...
That's 1,000th.
1,000th. That's 1 over 1,000. That's 1 over 1,000. See how it's going to get super, super, super small? Thanks, man.
Want to try this one first?
Sure. Yeah. I got some time tonight, so.
Yeah, I'll email you the login for it and add you a local one.
Okay.
Otherwise, you're not going to be able to install it. Got it. So
Okay.
try that one. Let me know if it's going to be usable.
Excellent. Thanks so much. Appreciate it. What? Okay, so that's the shape that it has. Now here's what happens. If we say instead of y equals 10 to the x, if we have y equals 1/10 to the x power, now that's different. Okay? If you put in a positive number, like 1/10 to the 3rd power, is that going to make it bigger or smaller?
Smaller.
It's going to make it smaller. So this one is going to start large, and then it's going to get small. But notice that it is never going to cross the x-axis. It always stays above. You don't actually get negative values for the output. You just get very small numbers for the output. So that's the parent function for an exponential function. What I also need you to understand is that there is another number that we're adding to our information. So the number 1 is very important. The number 0 is very important. The number pi is very important. We talked about the number I in the last unit. That's a really important number. Well, the important number you're going to learn in this unit is E. And E is a number 2.71828, so on and so forth. It never repeats itself. It is irrational. And I can show you later how we compute it, but it's really a base that we use for how things grow in nature. So for example, if we're trying to model the rate at which bacteria multiply, this is something that we would use. Okay, sorry about that. So I have y is equal to e to the x. Because the base is greater than 1, it has this shape. But if you have y equals e to the negative x, that's the same as y equals 1 over e to the x. And that would have this shape. So those two shapes of exponential functions, if the base is bigger than 1, it does the first one. If the base is between 0 and 1, it does the second one. Okay? Can you keep those in mind? All right, let's try a few practice problems then, okay? Sketch a graph of the function, state the domain and the range and the asymptotes. Domain, range, and the asymptotes. And we'll also label a point on the graph. Y equals 4 to the x. Notice how 4 is a number bigger than 1, so it's going to have this shape. It goes through the coordinate 0, 1. I will list the domain, the range, the asymptote, and a point that it goes through. For an exponential function, the domain is always all real numbers. All real numbers. The range, in this case, is from 0 to infinity. The asymptote is this imaginary line right here. It is a horizontal line, and so it is y equals 0. And the point that it passes through is 0, 1. What's different about the next graph? Yes, 1/4 is less than 1, so instead of starting down and finishing up, it will start up and it will finish down. And it goes through the coordinate 0, 1. The domain is always all real numbers. What is the range? 0 to infinity yet?
Mhm.
It goes through the coordinate 0, 1. And the asymptote is y is equal to 0. Notice how the first and second graph have the same characteristics, but the graph does look different. Okay. So letter C, is it going to look like letter A or letter B? How come? Because the base is more than 1. Great, you got the idea. We move along. How is D going to look different?
It's gonna look like question 2,
Okay,
maybe.
is the base bigger than 1 or smaller than 1? It's
Less than 1.
so just to be clear, this is not y equals -8 to the x. This is y equals 8 to the x, and then we multiply it by a negative. What happens when the negative sits on the outside of a function?
It just
Creates a
flips.
vertical flip. So that's what's going to happen here. You're going to see the flip of a function. Okay? So, it's going to go like this. So if it created a vertical flip, instead of going through 0, 1, what's it going to go through now? 0, -1. I have the domain, the range, the asymptote, and the point. We already said it goes through 0, -1. What is always the domain?
All real numbers.
All real numbers. What is the range in this situation?
Negative infinity, 0.
Yeah, it goes from -infinity on up to 0. And the asymptote is that y equals 0, that horizontal piece. Any questions on that example? What's going to be the transformation for letter E?
Down lower.
Down 4 units. So this asymptote is going to move down 4 units. 1, 2, 3, 4. So instead of sitting at 0, the asymptote is going to sit down 4 units here. If it used to go through the coordinate 0, 1, and it shifted down 4 units, what's it going to go through now?
0, 5. -3.
0, -3. This helps somebody during third hour when they saw this. Notice that if you plug in the coordinate 0 for x, you get 3 to the 0, which is 1 minus 4 is -3. See how it produces that point for you? Okay. So we have domain is all real numbers, range, asymptote, and point. We've already identified it goes through the point of 0, -3, and the asymptote is y is equal to -4. What is the range? Looks like I'm going from -4
infinity.
to infinity. Don't actually draw it, but there are 3 different transformations that are happening with letter F. See if you can talk to the person next to you, identify 3 transformations that are taking with letter F. Go, talk.
You think it was like all the numbers for the domain and you get the power of number 2.
Okay, the first thing I want to see from you is that you understand that instead of being shaped like that, it's going to be shaped like this. Does everybody see that? Second thing is that the +1 will shift it up 1 unit. And finally, the third thing is that the -2 is going to shift it right 2 units. So as I go ahead and I kind of re-examine this drawing, okay? The parent function would go through 0, 1. So if it shifts it right 2 units, the new point is going to be over 2, so at that red dot there, and then up 1, it'll shift it up 1 unit. So that new coordinate, instead of being at 0, 1, it's going to be at 2, 2. Second thing is, if I shift it to the right 2 units, does that change the asymptote?
No.
It's got a horizontal asymptote, and shifting it right is not going to change that. Shifting it up 1 will change the asymptote. So the asymptote is up 1 unit, so your graph should look like this. We have our domain, our range, the asymptote, and a point. We identified that the domain is all real numbers. The point is located at 2, 2. The range is going to be from 1 to infinity, and the asymptote is y is equal to 1. Any questions on that one? Okay, we'll finish off with these pieces. These are pretty easy, but just need to make sure you're doing them right. It says to find the exponential function that passes through the points. You want to write an equation of y equals a to the x. Kind of like we used to write equations for y equals mx plus b. That's what we used to do. And we would write, say, y equals 3x plus 4, okay? So we want to figure out what the value a is in this situation. Notice that these all go through what coordinate? 0, 1, because they're exponential functions. It also, this one goes through 225. So what that means, if I have y is equal to a to the x, the y value is 25, and the x value is 2. So what would the base be in order to make that equation true? 5. So therefore, sometimes people write a is equal to 5. That is not the correct answer for the test. You need to say y equals 5 to the x. That's an exponential function, okay? A equals 5 simply states a number. The next one, I've got a negative number here. So I have y equals a raised to the x power. So the y value is 2/3. What number do you take to the -1 power to get 2/3? What does it mean to take something to the -1 power? You flip it. What number did you flip to get 2/3?
3/2.
So a is equal to 3/2. So you have y is equal to 3/2 raised to the x power. Letter C, we have y is equal to a to the x. My y value is 8. A to the third. What number do you take to the third power to get 8? So y equals 2 to the x. And then we have 1/10,000 is equal to a to the 4th. What number do you take to the 4th power to get 1/10,000? 1/10. 1/10. So a is equal to 1/10. There are two ways to write this. You could write y is equal to 1/10 raised to the x power. Notice that 1/10 is the same thing as 10 to the -1. So you could also write as y equals 10 to the -x. Those are the same, however you want to write them. Okay, and that's that. I will make sure that I have these answer keys posted before you head off. Great. I hope that you guys really enjoy your Thanksgiving break. We got one more day tomorrow. Today is basically Thursday, right? Tomorrow's Friday. We have play practice over break. Oh, wow, good for you guys. We have wrestling over break. We have robotics over break. All right, some groups are getting a little bit of break, others are starting up. Any basketball players here? Any swimmers here? I heard Alex was considering diving this year for the swim team.